Half a day students, today's lesson we're going to be going over the first part of topic 14, which is about linear equations and two variables. This first part is going to be dealing with graphing. So first of all, a linear equation is an equation whose graph is a straight line. We went over some of this in class, but we'll just try to cover all of topic 14 in a couple of videos. So in order to pair in the form will give us a point on the graph, which is our coordinate plane. It's important to note that this here is our x-axis, and this here is the y-axis. Okay, so the y is the vertical, x is the horizontal. So each of these values represents one x and one y on the plane. So A occurs when x is 6 and y is 3. So we're actually going to graph this point here with this. I'm going to find where x is 6 and y is 3. And I'm just basically lining it up and finding that one point right there. X is 6, y is 3. And you should label them. This is letter A. 5, 0. X is 5, y is 0. C, and that's B, sorry. C, -2, 5. X is -2, y is +5. So on the left 2, up 5. Looking at D, sorry, there should be a comma right there. X is 0 and y is -4. So I'm going to find where x is 0, that's right in the middle. I'm going to go down to -4. And that is my D. This one up here is C. Now we're going to be going into looking at the different forms of linear equations. So we have slope-intercept, point-slope, and standard form. The one form that we're going to be using the most often and is the easiest to work with is the slope-intercept form. Point-slope is also useful when given certain info, for example, when given a point and a slope. Standard form, it's not super typical for people to want to use, but the reason that people like it is that there are no fractions or decimals. A, B, and C are all integers. So for our first form, slope-intercept form, y equals mx plus b, we're actually switching out m and b, where m is our slope and b is the y-intercept. Okay. Point-slope form, the ones that switch out are y1, x1, and m. M is again the slope. x1, y1 is actually a point on the line. So we have a slope and we have a point. Standard form, A, B, and C are all changed out. They're all integers. Okay, none of them represent anything explicit on the graph, but you can solve for y to find them. So we're looking at graphing linear equations in slope-intercept form. We're going to take a look at what a slope is and what a y-intercept is. So looking at this is in slope-intercept form because it's in the form y equals mx plus b. I can easily see my slope is 2/5. My y-intercept is -3. 2/5, slope just means rise over run. Please excuse my dog. Okay, so rise over run just tells me how much they go up over how many that goes from the left to the right. We'll go over that again. So B, my y-intercept is -3. So this tells me that my line crosses, it intercepts my y-axis, my vertical axis at -3. So basically what I'm going to start off with is graphing a point at y equals -3. Okay, so this is my y-intercept. So you should always plot the y-intercept first and then move according to your slope. My slope is 2/5. So I know my line is going to be going up 2 and to the 5 to the right. So on the graph, I'm going to do just that. I'm going to go up 2. So I have going up. Let me change this to red or yellow just so I can see it there. Up 2, 1, 2, and then 5 to the right. 1, 2, 3, 4, 5. Okay, then we have a second point there, right at that point. Okay, and then from there, just connect your 2 points, and then you have your line. We'll try another example with a negative slope. So here we have y equals negative 3x plus 2. So I notice something right away. My slope is negative 3, which is an integer. And I'm used to working with fractions because it's rise over run. So basically, when I'm writing down this slope, negative 3, I know that any number is equivalent to the same number divided by 1. So if I wanted to force this to be a fraction, I'll just divide it by 1. So it's negative 3 over 1. So I know I'm going to go down 3 because it's negative. So my rise is now negative. It's going down 3. And I always go over 1 to the right 1. So I have that. My y-intercept is positive 2. So I'm going to have a point at positive 2. And I'm going to have another point at where I'm going to move. So I'm going to move according to my slope again. So I'm going to move down 3. 1, 2, 3. To the right, 1. Second point right here. Then I'm just going to connect them. Second line. And it's always helpful to have some kind of straight edge. Doesn't have to be a ruler, but something that can help you keep your lines straight. Now we're moving into graphing vertical and horizontal lines. So whenever I have only one variable present in my equation, it's going to be either a vertical or horizontal line. So something to look at right here is I want to see, first of all, where is the y value 2? Okay, so I know that y is 2 right at this point right here, right? If I can name any other point that y is 2, okay, I know y is also 2 right here. Y is 2 right here. So basically the line is going to be where all points have the y value of 2. So this is actually going to be a horizontal line. It's kind of easy to just think of y as a vertical axis, so it's going to be a vertical line, but this is not true. It's wherever y value is 2, and that's actually going to be everywhere horizontal where y is 2. Looking at x equals negative 3, we're going to remember the same thing, that x value, so we're going to find where's x negative 3, and I know now that everywhere on this line, this vertical line, is going to be x equals negative 3, right? And then this one is there. Now we're going to look at graphing linear equations in standard form. So this is standard form, 2x plus 3y equals 6. We've said this before. I cannot identify any slope, y-intercepts, anything like that given this form. There are two ways to do this. One way is if I was to just solve for y. So if I was to put this into slope-intercept form, I could easily find my slope and y-intercept. And I'll show you this way right now. So if I had 2x plus 3y equals to 6, slope-intercept form is y equals mx plus b. So if I was to solve for y, then that would be in y-intercept form. So first of all, I would just move this 2x minus 2x minus 2x in the front there, right? So I have 3y equals negative 2x plus 6. Now I'd have to solve for y by dividing by 3. Divide by 3. I'm dividing both terms by 3. So y is equal to negative 2 over 3x plus 2. So now I can plot this. Negative 2 over 3. So I have a slope of negative 2 over 3 and a y-intercept of 2. So y-intercept, plotting that first. I have this, negative 2 over 3. I know I'm going to move down 2 to the right 3. So I have down 2 to the right 3. A second point right here. From there, we can just connect our 2 points. Okay. The line's not that straight, but you get the point. doing the same thing again, I'll just solve for y. So if I was to have, sorry, let me just get the appropriate pen here. Negative 4x plus 2y is equal to 8. I'm going to add 4x. Add 4x over here in the front. Okay, so we have 2y is equal to 4x plus 8. Divide everything by 2. So I have y is equal to 2x plus 4. Same thing again like we did before. I'm going to force this to be a fraction. So my m is 2 over 1. So I'm going to go up 2, right 1. My y-intercept is 4. So starting at 4, I have a slope up 2, right 1. Second point right there. Now I can connect them. There you go. Taking it one step further, we're going to deal with linear inequalities. So this one we're going to do with some shading. Okay, so y is less than negative 3x plus 2. So first thing you're going to do is graph the line y equals negative 3x plus 2. But we're going to look at differences. If I have less than or greater than, then I'm going to use a dashed or dotted line. Okay, if I have less than or equal to or greater than or equal to, I'm going to use a solid line. So if I have this or equal to on the bottom, this line on the bottom, I'm going to have a solid line. So this one is dashed, so does not have an equal to, so it's going to be a dotted or dashed line. Okay, so y equals negative 3x plus 2. I know I'm going to have a point at my y-intercept, which is 2. My slope is negative 3 over 1, down 3, 1, 2, 3, right 1. Okay, so now when I connect these, I'm no longer going to use a solid line. I'm using a dashed or dotted line. Okay, and when I'm going to deal with or look at how to shade, if it's in slope-intercept form and it says y is less than, I can automatically shade down. If not, it's not always in that form, so we could actually test a point. So we want to test a point to see if it makes this inequality true or not. Because if it makes it true, then we're going to shade everything on the one side. So basically everything on one side of this line is going to be true, everything on the other side is going to be false. So if the point that we test is on the true side, then it would make it true and everything on that side would be shaded. So if I was to test a point, the easiest point to test is always 0, 0. So if you can, if your line does not go through 0, 0, test it. So test 0, 0. So we're going to test it by plugging it into our inequality. If y is 0, 0 is less than negative 3 times 0 plus 2. Negative 3 times 0 is just 0. 0 is less than 2. We're going to think about, is this true or false? This is true. 0 is definitely less than 2, so that tells me that 0, 0 makes this inequality true, so everything on the side that has 0, 0, I'm going to shade in, because everything on this side is going to make that inequality true. And if it were false, if it was, for example, like 0 is less than negative 5, which is false, then I would shade the other side. Now I'm working with how to graph a linear inequality that's in standard form. So I'm going to do the same thing, solve for y, but we're going to keep in mind the properties of solving inequalities, and which the most important one is to flip the inequality symbol whenever you multiply or divide by a negative number. So that's something that we're definitely going to be having to do in this example. So solving for y, I'm going to first of all move this x. So I'm going to subtract x. I'm going to place it right there in front of the 6. So we have negative 3y is less than or equal to negative x plus 6. Now dividing by negative 3, since I have negative 3 that I'm dividing by, I'm actually going to flip this to be greater than or equal to instead of less than or equal to. So we have greater than or equal to now. So negative 3y divided by negative 3, I'm left with y is greater than. Negative divided by negative is positive, so we have, actually to make this an easier fraction, I'm going to put 1 over 3 x minus 2. Now that it's in slope-intercept form, this is easy for me to graph. My y-intercept is negative 2. So I have a y-intercept of negative 2. I have a slope of positive 1 over 3, so I'm going to go up 1, 3 to the right, up 1, right 3. Now I'm going to do this. Since I have less than or equal to, this is going to be a solid line. So I'm actually going to connect it with a solid line. And since it does not go through 0, 0, I can actually test 0, 0. So I know that 0 minus 3 times 0 is less than or equal to 6. 0 minus 0 is less than or equal to 6. Is this true? Yes, it's true. So I'm going to actually shade the upper portion of this graph. Since I already solved for y, you can also see that y is greater than this equation. So that means if I see greater than, I can automatically shade up. So either is fine. They both work. And that's it for the graphing portion of topic 14. The next video will go over the algebraic portion of the topic.